Okay. So when we are doing pH calculations, there are essentially four different pieces that we can look at. There's the pH, which is the power of hydrogen. There's the pOH, which is the power of hydroxide. There's the concentration in molarity of our H plus ions. And then there's the concentration in molarity of our hydroxide ions. Now, there are several relationships that we need to know. pH is equal to the negative log of our concentration of H+. Okay? The same is true with pOH. pOH is equal to the negative log of the concentration of hydroxide ions. So those ones kind of go together. Same idea, different perspective. One is looking at it from the hydrogen perspective, from the acidic perspective. One of them is looking at it from the hydroxide perspective, the basic perspective. Now, we also know that the pH plus the pOH is going to add up to 14 because that is our scale. Our scale goes 0 to 14. So you take your pH plus your pOH, and that's going to give you a total of 14. The other thing that we know is that when we multiply the concentration of hydrogen times the concentration of, that's hydroxide, that's going to get us 1 times 10 to the minus 14th. And that's where the pH scale comes from. It's the relationship between the product of these two values. So based on essentially these four equations that we have here, we can go from pH to H, we can go from H to OH, we can go from OH to pOH, we can go all the way around this circle, or square if you want to call it that. So let's talk about how to take these relationships and plug them into these directions. So if I want to go from H to OH, my OH concentration is going to be equal to 1 times 10 to the minus 14th divided by the concentration of my H. Okay, that's this equation solved for your OH. If I want to go back the other direction, OH to H, my H plus concentration is equal to 1 times 10 to the minus 14th divided by the OH concentration. So again, it's this equation solved for the H concentration value. Okay? So I can go this way using this equation. I can go this way using this equation. But they both stem from this equation. All right? pOH to OH. So first of all, our normal equation, this one, if I'm trying to find the pOH, so going this direction, I'm actually going to rotate my paper so that I can do it correctly. My pOH is going to be equal to the negative log of my OH concentration. Okay? If I want to go back the other direction, what if I have the pOH and I want to use that to determine my OH concentration? I'm going to use the inverse log, okay? So to do the inverse log, and I'm going to show you the buttons on your calculator to do this. Your OH concentration is going to be equal to 10 to the power of your negative pOH. Okay? So, looking at our buttons on our calculator, we have our log button right here. So let's say that my hydroxide concentration is 1.5 times 10 to the minus 13th. So to find the pOH, I would do negative log of 1.5 times 10 to the minus 13th. Remember, we use the second comma to do the exponent. That gets me a pOH value of 12.82. Okay? Now, if I want to go back the other direction, so this is my pOH, I'm going to do second function log button. Second function log button. See how that gets me 10 and then a little exponent? So then I would do the negative pOH, which was 12.82. That gets me the 1.5 times 10 to the minus 13th that I started with. So you can go forwards and backwards using the same button. Forwards is log, second log is backwards. Okay? We can do the same thing over here with pH and H, okay? So to go from H plus concentration to pH, my pH is going to be equal to the negative log of my H plus ion concentration. And the same thing is true here. If I want to go back to the H plus, my H plus concentration is going to be equal to 10 to the power of the negative pH. Okay? And then this last field down here, going between pH and pOH, is this equation right here. So if I want to go from pOH to pH, the pH is going to be equal to 14 minus the pOH. The same is true going the other direction. The pOH is going to be equal to 14 minus the pH. So all of these little equations in red are all derivatives of these four equations right here. So this equation gets us this equation gets us this equation gets us these two, and then this equation gets us these two. So it's all sort of derivative of that. Okay? So let's just work a couple of problems together. You have an H plus concentration equal to 1.3 times 10 to the 6th, 10 to the minus 6th molar. Okay, let's find the pH and the pOH. All right, so pH from H is going to be equal to the negative log of the concentration of H plus ions. So we're going to take the negative log of 1.3 times 10 to the minus 6th. So in our calculator, we do negative log 1.3 second comma negative 6. That gets us 5.886. We're going to round that to 5.89. So that gets us a pH of 5.89. To find the pOH, that's going to be equal to 14 minus the pH. We just calculated the pH as 5.89, so we're going to do 14 minus 5.89. That gets us 8.11. And that would be our pOH. So now let's use our pOH to find our OH minus concentration. So OH minus is going to be equal to 10 to the power of the negative pOH. So in that case, our pOH was 8.11, so 10 to the negative 8.11. So when we put this in our calculator, we're going to do second log. That gets us our little 10 and the exponent. We're going to type in the negative 8.11. That gets us 7.76 times 10 to the minus 9th molar. Okay, so we've gone on the whole journey. We've got H plus to pH to pOH and then to OH. So we did the entire circle by doing this. All right, let's start with a different value. Let's say that they've told us that the pH is equal to 2.6. Let's find the H plus and the OH minus concentration. All right, so to get from pH to H, we're going to use the inverse log. So H plus is equal to 10 to the power of the negative pH. So we're going to do 10 to the power of the negative 2.6. So second log negative 2.6 gets us, now this didn't give it to me in scientific notation, but I'm going to change it to scientific notation. 2.51 times 10 to the minus 3rd molar. So there's my concentration of H plus. Now I want to find from that my concentration of OH. Well, we know that the concentration of OH is going to be equal to 1 times 10 to the minus 14th divided by the concentration of our H, which we just solved for here. So we're going to do 1 times 10 to the minus 14th divided by 2.51 times 10 to the minus 3rd. So 1 second, comma, negative 14 divided by 2.51 second, comma, negative 3. That gets me 3.98 times 10 to the minus 12th molar for my OH. So then we had the pH, we got the H and the OH, so the last thing to find is the POH. So POH is going to be equal to the negative log of our OH minus concentration. We just calculated that value right there, so we're going to take the negative log of 3.98 times 10 to the minus 12th. So in our calculator, negative log of 3.98 second, comma, negative 12. That gets us 11.4 as our POH. Okay, so you can use these equations to go around the circle, okay, to get from one value to the next, to the next, to the next. It's just a series of equations. Now, on your test, I will let you use this little circle, but next year in AP, all they would give you is these things, and you would have to know how to change them into these other equations. So, little step of help here this year in honors. Next year in AP, we would start with these and have to work from there.